In this video, we will introduce the different options to provide interconnection solutions on the Internet. To better understand those concepts, we will briefly talk about the early Internet in the 90s and its evolution. As you will realize, interconnection costs have always been an issue to build a global and affordable Internet service of high quality. DE-CIX and other Internet exchanges played a key role in building today's Internet. But don't let me get ahead of myself. Let's start from the beginning.
A long time ago in Germany, in the 1990s, there were only 3 commercial internet service providers. Each ISP had a separate connection to the US using a really expensive transatlantic link. German ISPs were not interconnected between each other, so all traffic exchanged between them had to cross the Atlantic twice, generally making it really slow and expensive. Then we have an idea. Why not exchange traffic directly? One possible solution would have been using direct cables, but unfortunately, each of these early ISPs was in a different city, and cables and leased line were also expensive. So the idea of an IX arose. Why not to meet in the middle? And with this, DE-CIX was born. Meeting in the middle is the simple idea behind not only DE-CIX today in the larger internet exchange in Europe, but also any other IX. The direct interconnection of providers means that each ISP only needs to rent one single line to one location, in our case, Frankfurt, and everybody gets automatically interconnected and can start exchanging data traffic. This is called peering.
Put simply, peering is the exchange of data between different networks on a cost-neutral basis. All kinds of networks, like carriers, internet service providers, and network operators, need to exchange data in order for the Internet to work. The data exchange is either agreed on a bilateral payment basis for transit upstream or on cost-neutral basis, also known as peering. Let's illustrate this by means of an example. Here, a typical internet service provider, shown in blue. This ISP has all kinds of customers, domestics, businesses, mobile, and so on. This ISP is connected to the outside world via the 2 so-called upstream or transit providers. Upstream providers are another form of ISP, which deliver internet connectivity to other networks, in this case the blue provider, for a fee. At the same time, these upstream providers are also connected to other providers. The picture is simplified because there may be further connections between both upstream providers. Another ISP, shown in green, also has connectivity to an upstream provider which is interconnected with other providers. This is a simplified illustration of the Internet architecture. To transport data from the blue to the green network in this case, we need to go firstly through one of the upstream providers, and onto their upstream provider, and onto the upstream provider of the green ISP, and finally to the green ISP itself. Well, this can be also done more easily by just interconnecting the green and the blue ISPs. Now the traffic can travel directly from between the 2 networks, shortening the path that the data needs to travel. This is the great advantage of peering. Peering may happen on multiple levels, for example, between the blue and the green ISPs, or between their upstream providers, and the same goes for the major top-level providers. There is a kind of hierarchy of peering, which means that peering usually happens between equal, similar-sized networks. Peering happens on all network levels from the bottom to the top levels. Here, the top providers are the so-called Tier 1 networks. These are generally major telecommunication companies, and they often only peer among themselves. The definition of a Tier 1 ISP is a provider that can reach all major networks on the Internet and does not need to purchase upstream from anyone. Tier 1 is quite an exclusive club of large ISPs. There are about 15 in total around the globe. Have a look at the Wikipedia to find the list. To conclude, we can ask ourselves why peering makes sense. In the early days of the internet, peering was of course cheaper than having upstream and transatlantic capacity, and it kept traffic from going over the Atlantic twice. Today, the upstream prices have reduced in the meantime, but peering is still very important because it keeps local traffic local. It keeps the latency low, and it also helps the provider to decide along which route to send the traffic. This decision depends on different criteria, such as which route is cheapest or which route has the best and lowest latency. An internet exchange helps to facilitate peering by offering a meeting place for many providers. For example, DECIX in Frankfurt has more than 1,000 peers. To conclude, if you want to exchange traffic with other networks on the internet, peering is a good option. And if you want to peer, an IX like DECIX is the best place. Thanks for joining this course from the Interconnection Academy.